Okay, we have to see how to integrate this rational function, which is 1 over x square plus a square. Suppose you have to integrate something which is, let's say you have to integrate 1 over 1 plus x square dx. Before I tell you how to integrate this, you could be asked to integrate 1 over 1 minus x square. Do you have any idea how to integrate this 1 over 1 minus x square? Hmm? Very quickly, please tell quickly. Hmm.
Sir, UV, VU
Nine.
minus U.
No, 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 no. You will have to write its partial fractions. Okay, you have done this already. This is 1 over 1 minus x square. This can be written as, this can be factorized. This is 1 plus x into 1 minus x. This has already been covered. You will write its partial fractions and then you will integrate this. Okay? Secondly, you can have 1 over 1 plus x square. And then suppose you have x over here, like let's say this is x over 1 plus x square dx. Now, this is a case where you see that, yes, 1 plus x square can be differentiated, and like its derivative can be obtained in the numerator here. 1 plus x square's derivative is 2x. So you multiply this 2 and you divide it by 2. So this is going to be half ln uh, 1 plus x square plus c. That is the integral of this x over 1 plus x square. But if you just have this 1 over 1 plus x square, you can neither factorize this, you can't have its derivative up here. So then you must recall, one thing is clear, that you can't write its partial fractions, you can't write this resulting into a logarithmic integral. Then you have to think about the derivative of tan inverse of x. Okay, you have just done that. The derivative of tan inverse of x is 1 over 1 plus x square. Okay, so this means that if you integrate this 1 over 1 plus x square, this should be equal to this tan inverse of x, okay, plus c. Do you see that? Like, first of all, you have to see that if you can write the partial fractions, then you should see if you can have, you can manage the derivative up here. If both of these things can't be done in case of a rational function and you have to integrate that, then you have to think about this third option, which is this, the tan inverse of x. Okay, now look at this, this typical form when you have to integrate 1 over x square plus a square. Now you have this 1 over x square plus a square. Okay, right? So again, mm, this is 1 over, let us write it as 1 over a square plus x square. Okay? You must always have 1 plus and then something square over here. So we'll be taking a square common from the denominator. This is 1 plus x square over a square. Okay, so this is now 1 over a square into this, 1 plus x square, x over a, in fact 1 plus x over a whole square. Okay, now suppose we are integrating this, so we can write it like this. Okay, now this is 1 plus x over a. When you differentiate, for example, when you differentiate tan inverse of 2x, okay, when you are differentiating this tan inverse of 2x, you get 1 over 1 plus 2x square. Okay, and you have its derivative up here, that is derivative of this 2x. Okay, so similarly, if you want to integrate this, you want to write this in terms of tan, so you have to see that, okay, this is 1 plus x over a whole square, so you must have 1 over a over here. Okay, You are multiplying this 1 over a, you will divide this with 1 over a as well. So this would be like this. This will be written like this. Okay? So I have introduces 1 over a myself. So when I write 1 over a, I should, if I multiply with 1 over a, I should be dividing this with 1 over a as well. So when I divide this with 1 over a, it becomes a over 1. So now this can be simplified here. So we have 1 over a tan inverse of x over a plus c. Okay? That is how you will be doing that. Now, either you remember this or you can do these steps every time when you are required to integrate. Okay, now look at this. Suppose you have to integrate. Let me write here a question. Suppose you have to integrate 1 over x square plus 4. Okay, you can directly write it as 1 over 2 tan inverse of x over 2. That's it. Okay, if you're good, if you are good to remember the things, you can write this directly like this. But if you don't remember this, you only remember the tan inverse thing, then you will have to show all the working. Look at this, you will be writing it as, first of all, you will take 4 common from here. Okay, this 4 will come outside and this will become 1 plus x square over 4. Okay, I've taken 4 common, and then this becomes 1 over 4, and this is 1 over 1 plus x over 2 whole square. Okay, what is the derivative of x over 2? That is a half. So you will multiply it with 2 over 1 as well. This is 2 2s are. So now you can write it as half tan inverse of x by 2 plus c. So choice is all yours, man. Okay? Let me take you to the exercise where we have these questions. Look at this. He has shown you that if it is 1 over, if you can look at this, if it is simply 1 over x square plus 1, its integral is tan inverse of x plus c. If it is 1 over x square plus a square, its integral is going to be 1 over a tan inverse of x over a. So just remember the whole process behind this, that how this integral is going to be like this. Look at this. This is 1 over x squared plus 25. This is directly written as 1 over 5 tan inverse of x over 5. If you don't remember this, see how will you will do doing this. You will write it like this. You will take 25 common from the denominator. Okay, this will become 1 plus x square over 25. Next, you write it like this. This is going to be 1 over 1 plus x over 5 square. Okay, and now you need to have its derivative here, which is 1 over 5. So you multiply this by 5 by 1 as well. This is cancelled by this. So all of this becomes, this is going to be 1 over 5 tan inverse of x over 5 plus c. Okay, got it, boy? Hmm? So either
Yes,
you,
sir.
yeah, either you remember this, you can write this directly, or you can show all this working. Okay. Okay. Let's see what do we have next. Now you see here for this these kinds of questions here. Thing is that you should always have 1 over 1 plus x squared kind of a form. Okay, and this is 1 over 2x squared plus 3. So I'll first of all be writing it as 1 over, I need to take this 3 common from here. I'm writing this 3 out here. So now this is going to be 1 plus 2 over 3x squared. Okay, and then this should be a square over here. This is going to be 1 over 3, and you see this is 1 plus under root 2. Let me write all of this in square root. Under root 2 over 3x whole square. Okay, so what is the derivative of under root 2 over 3x? That is going to be under root 2 over 3. So you will multiply it here by under root 3 over 2. That is its reciprocal. Okay, so this is going to give you This is going to be 1 over 3 under root 3 over 2. And this becomes tan inverse of under root 2 over under root 3 x plus c. Yes? Hmm? And the same
Yes, sir.
thing is written like this over here. Okay? So it's time for you to practice these questions. Okay? Let me take you down here in the exercise. Okay? So you see, you have to write all of them in the form uh, 1 over 1 plus x square, which is going to be tan inverse of x plus c. ठीक है? चलो try करो. It's never easy to rote memorize this formula. So it's better if you remember to write this in the form 1 over 1 plus x square, okay? And then you write this as tan inverse of x. If you have x square over here, there should be 1. Now suppose if there is 1 over 1 plus 2x whole square, you must have 2 over here, okay? If you have, let's say, 1 over 1 plus x over 2 whole square, you need to have half over here, okay? Like this is going to be tan inverse of x, this is going to be tan inverse of 2x, and this one is going to be tan inverse of x over 2 plus c. Okay? Now look at this 1 over x squared plus 9. If you look at this 1 over x squared plus 9. So first of all, I'll write it as a 9 plus x squared. Okay? This becomes 9 plus x squared. Then I have to make this first term 1. So I'll be taking this 9 common from the denominator. So when you take 9 common from here, this becomes 1 plus x squared over 9. Okay? And then you see that this x squared over 9 is basically, you have to write this as a whole square. So this is the square of x over 3. Okay? So this is 1 over 9. So you write this as 1 plus x over 3 whole square. So you need to have x over 3's derivative here, which is 1 over 3. You're writing this yourself. You're adding this into the statement. So you will write its reciprocal here as well. Okay? So now we are ready to integrate this. These are cancelled. So this is going to be 1 over 3. All of this would result into tan inverse of x over 3 plus c. That's it. Okay. Sometimes you don't have this as a square. Like let me try this e part, for example. If you look at this e part, first of all, let me cover this area so that I can work here. Okay, let me cover all of this. Okay, so this E part has, um, this is 1 over 4x squared plus 3. Okay, so I'll shuffle them. I'll write this 3 first. 3 plus 4x squared dx. Okay, and you see next is you have to make 1 instead of 3 here. So we'll take out this 3 common from the denominator. That is why I'm writing this as 1 over 3. This is being taken common from the denominator. So now we have 1 plus 4 over 3x squared dx. Now look, this should be written as a perfect square. Now we are happy with the 4. This is a 2 square, but this 3 is not a perfect square over here. So you will have to make it a perfect square by hook or crook, okay? So we'll write it as 1 plus 2x over under root 3 whole square. See, this has to be a whole square with this x in it. So the derivative of this 2x over under root 3 is 2 over under root 3. Hannah? And I'll multiply this with under root 3 over 2 over here. Okay? And now this becomes under root 3 over 6 tan inverse of 2 over under root 3x plus c. That is what you are supposed to do. Look at this f part. Let me do that quickly, this f part. And this was, by the way, e part here. Now, if you look at this F part, this F part is, um, now he has kept them in the right order. He has kept the x square in the later in this expression. So I'll need to take this 2 common from the denominator. So I have 1 over 1 plus 3 over 2 x squared. Okay, man. Now this has to be a whole square. So we'll be writing this as 1 over 2, and this would be 1 plus under root 3 over under root 2 x whole square. Okay, and we need to have its derivative. Let me write this as a whole under root 3 over 2. So I'll be multiplying it with under root 2 over 3 over here. Okay, so finally this becomes, all of this is going to become, we have here under root 2 over 3, and then there is a half outside, and this is going to be tan inverse of under root 3 over 2x, like this, and then there is a plus c. Yes, I think this should be enough for you, so that, I mean, for you to be able to practice these, try these questions yourself. Okay.